Good morning. Today is Thursday, May 21st. We are going to start finishing up Unit 4, Lesson 1 by reading pages 22 to 23. These pages will help us see how waves are similar and different. So how water waves, waves on a string, and sound waves are similar and different. Your reading assignment is going to be to complete page 25, and we'll look at that in just a minute. Your writing activity is to complete the writing activity on page 24 using complete sentences and thoroughly explaining your thoughts. So making sure you have topic sentence and supporting details. To get to the assignment, you could just click on the link here on the calendar and it will open up. All right, there it goes. So let's go down. We'll read it in just a second. Here is your writing assignment. Your writing assignment is to answer the questions below in complete sentences. So remember, we're looking at the similarities and differences between water waves, waves on a string, and sound waves. So you can look back into the text. When you go to answer these, it says, write down 3 similar patterns these waves have. So make sure in this space or when you type it up, you are using complete sentences to tell the 3 similar patterns these waves have. And then you're going to compare how the matter moves in each type of wave. So remember, the matter is a different object in each type of wave. Compare how they move. Your reading assignment is to check for understanding of what we read and show what you know. It says, think about how the matter moves in each wave. Oh, that's one of the questions you're going to have to look at for your writing assignment, comparing how the matter moves in each type of wave. In the reading assignment, we're going to think about how the matter moves in each wave. What else do you know of that moves in a similar way? Complete each statement to write an analogy. Remember, an analogy compares things that will help you remember how the matter moves in each wave. So here's a wave, and there's a matter. The matter in a water wave moves similarly to a blank because, so you're trying to compare the matter in a water wave to something else that moves similar and how they move similarly. So you will fill in the blank with what it is like, and down below you will tell how they are similar. Here is another wave in the matter. It says, the matter in a wave on a string moves similarly to a blank. So what is it the same as? Because, and how are they the same? So this would just be telling how they move, right? How the matter in a wave string moves, or how the matter in a water wave moves, what it's the same as. So here's another wave and matter. It says the matter in a sound wave moves similarly to a blank. So what does the matter move similarly to? Remember, back and forth. So what is it? What else moves back and forth? And why are they the same? Because they move back and forth, or whatever you come up with. So we're going to keep those in mind as we read, and we'll review them when we're finished reading. This section is how waves are similar and different. You have learned about 3 different examples of waves. These 3 waves have 3 main similarities. Waves have similarities. The first similarity is that each example of a wave has a repeating pattern of crests and troughs. In water waves and waves on a string, the crests and troughs are the highest and lowest points in the wave. In sound waves, the crest is where the matter is most pushed together, and the trough is where it is most spread apart. And you can see those here, crests and troughs, crests and troughs. And in this, crests and troughs, crests and troughs. But in the string, or not in the string, in the sound wave, it is trough and crest, trough and crest. The second similarity is that in each example, the crests and troughs move through matter. In water waves, the crests and troughs move along the surface of the water. And so here, remember, if it was a boat, it would move along the surface. In waves on a string, they move along the string. So remember, we had the yarn tied here, and it would just move along it. It wouldn't move front or back. It would just stay where it's at. Just move with the string. In sound waves, they move through the air. So remember when the yarn was stuck on there. Another similarity is that in each example, the waves spread out in all directions that they can. Think about dropping a pebble in water. The wave spreads out from the pebble. But the wave does not move in only one direction. It spreads out in all directions and forms a ring around where the pebble fell. Waves on a string also spread out in all directions. Think about holding a long piece of string in the middle with a friend on each side of you. Now suppose you shake the middle of the string back and forth to make a wave. Does the wave move toward just one of your friends? No. The wave moves in both directions along the string toward both of your friends. The waves spread out in all directions along the string. Sound waves also spread out in all directions. Think about clapping your hands, which causes a sound wave. Can people in front of you hear the clap? Can people behind you hear you clap? Can people on your left and to your right? People in all directions can hear you clap because the sound wave spreads out in all directions. So let's look back at how waves spread out. It says all 3 examples of waves are made up of a pattern of crests and troughs. What similarities and differences do you notice between the crests and troughs of these waves? So we just heard about the similarities. Let's look at the differences. Waves have differences. Along with these similarities, all 3 examples have different patterns as well. The way the matter moves in each example is different. Because of this difference, scientists classify waves by how their matter moves. If the matter moves in small circles, it is similar to a water wave. So remember when we wrote about the boat. If the matter moves side to side, it is similar to a wave on a string. If the matter moves forward and backward, it is similar to a sound wave. So they classify sounds based off of how their matter moves. So here's another image. An illustration, how a wave on a string spreads out. This wave on a string began in the center. Notice that the wave spreads out on both directions along the rope. This happens because all waves spread out in all directions that they can. So this is kind of like one of the similarities. If we held it here and we moved it, the wave would go both directions and just like when you clap and it moves out everywhere, and the rock, when you throw a pebble in water, it will spread out in all directions. So now, using what we just read, you are going to write down the 3 similar patterns these waves have. If you go back to the text, it will tell you the pattern and the similarities. Then you're going to compare how the matter moves in each type of wave. So here it tells us how the matter moves in each type of wave, how they classify the type of wave. Then you will go back to how they classify each type of wave and find something that moves similarly. So if you remember, the matter in a water wave moves in a circle pattern. What else moves in a circular pattern? And then why are they the same? How does a matter move on a string? What else moves that way? And why are they the same? How does matter move on a sound wave? What else moves that way? And why are they the same? If you have any questions, please ask your teacher.